questions 21 through 25 on the 2005 Grade 12 AMC 12B. A positive integer n has 60 divisors and 7n has 80 divisors. What's the greatest integer k such that 7 to the power of k divides n? So a little bit of a primer before we get started with this question. If you have, let's say, a number, let's call it n is equal to 2 to the power of 2 times 3 to the power of 2 times 5 to the power of 4. Okay, it's a number that I've broken down into its prime factors. And I say to you, how many divisors does it have? Well, what you do is you take the exponents and you add 1. So you take this first guy and you add 1 to it. Then you multiply it by the next exponent plus 1. And then the next exponent plus 1. Like that. So this gives me 3 times 5, which is 9 times 5, which is 45. So this number n has 45 divisors. So in general, if you have n is equal to, say, a to the power of x, b to the power of y, c to the power of z, and so on, right? I mean, it could be anything. If a and b and c are the prime factors, then the number of divisors is going to be x plus 1 times y plus 1 times z plus 1. All right? So that's the first part of this question. I just wanted to explain that before I get into the question stem. Now let's discuss this question here. We've given that we have some number n and it's got 60 divisors, right? Now, I have no idea what n is in terms of its numerical value, and I also don't know any of its prime factors, so I'm just going to create an estimate. Let's say its prime factors are a, b, and c. Let's make it simple for myself. I'll just have 3 prime factors. And I have to somehow get 60 divisors, correct? So I've got to create a situation where my exponents, just like how I did in the primer, when I multiply them, of course I have to add 1 each time. It's going to equal 60. Well, before I make a guessing game, let me just break down 60. What is 60? It's 2 times 3 times 5. Okay, that helps me out a little bit. So if this, let's say, is a 4, let this say is a 2, and this is a 3. I think that would do it, right? Because my number of divisors, if my n is like that, would be 3 plus 1 times 2 plus 1 and times this 4 plus 1, like that. And that gives me 4 times 3 times 5, which is indeed equal to 60. All right, so far so good. Now let's start talking about 7 to the n. We got 7 to the n. So using my exact same scenario there, I've got a to the power of 3, b to the power of 2, c to the power of 4 times 7. Okay? Now, 7 is really like 7 to the power of 1, right? So how many divisors do I have now? Well, in the exact same way, it'd be 3 plus 1, 2 plus 1, 4 plus 1, and 1 plus 1, correct? And if you do this math, you get 120. Now that's no good, because they tell us that 7n has 80 divisors. I got 120. So what did I do wrong here? Well, think about this for a second. Concentrate on this right here. We've got to get the number of divisors to be 80, right? I just got 120. So what did I do wrong here? I don't think I did anything wrong. You just have to understand that one of these, A, B, or C, is a 7. That's the only way you're going to get 80 divisors. That's the key to this question in my humble opinion. So which one of those are you going to make a 7? The A or the B or the C? Well, it just takes a little bit of fiddling around, I think. First, before I figure out if it's A, B, or C, I'm going to look at 80, right? 80 divisors. What is 80 broken down into prime factors? Well, it's 2 times 2 times 2 times 2 times a 5. Okay? So that really is like 2 to the power of 4 times 5 to the power of 1, like that. All right? Okay, does that help me? Perhaps. How about if I wrote it like 2 to the power of 2 times 2 to the power of 2 times 5 to the power of 1, like that. Which is essentially 4 times 4 times 5. I think this scenario I could figure it out. So we already have a 4, right? Because 3 plus 1 is 4. We already have a 5 because 4 plus 1 is 5. So if I can make the b a 7, this will work. It'll be a to the power of 3, 7 to the power of 3, and c to the power of 4. I made b equal to 7. Now how many prime factors? Well, obviously a, 7, and c are prime. But how many divisors do we have? Well, number of divisors. 3 plus 1, 3 plus 1, and 4 plus 1. So this is 4 times 4 times 5. 16 times 5, there you go, 80 divisors. So my 7n is of this form. Okay? And therefore, going back and looking at n is therefore a to the power of 3, 7 to the power of 2, c to the power of 4. All right? Now, the question is asking, what is the greatest integer k such that 7k divides n? So n divided by 7k. All right? Well, n is a to the power of 3, 7 to the power of 2, c to the power of 4, 7 to the k. Well, the largest k can be is 2. Because if k is greater than 2, this will not work. It will not divide. It will become it won't be an integer, basically. You know, that's the way to look at it. So it's a really interesting question, I think. So number 21, the answer is C. A sequence of complex numbers z0, z1, z2, and so on is defined by the rule zn plus 1 is equal to I times zn over the conjugate of zn, where zn is the complex conjugate of zn, and I squared is negative 1. Suppose that the magnitude of z0 is 1 and z to the 2005 is 1. How many possible values are there for z0? So a little bit of a primer before we get started here. If you're not familiar with complex numbers, then this question will basically be out of reach. So I encourage you to first review complex numbers. Complex numbers are essentially of the form a plus ib, like that. Sometimes also written as x and y. And just a few very simple things that I wanted to mention. Zn with the bar over it is the complex conjugate. And what that means is that if z is equal to x plus iy, and in this case, let's just call it zn, then the complex conjugate will be x minus iy. All right? And then this symbol here that looks like an absolute value is actually, in complex numbers, it's the conjugate. So for example, if zn is x plus iy, if you were to take the magnitude, it's equal to x squared plus y squared, the square root. All right? And just one more property, if you multiply the complex number by its complex conjugate like that, you get x plus iy times x minus iy, like that. And this gives you x squared minus I squared y, but I squared is equal to -1. That's a standard rule. They give you that in the question also. And therefore this becomes x squared plus y squared. It can also be represented as the square of the magnitude. All right, so I just wanted to get that all in there. So let's proceed with this question. So they tell us that we've got this rule here, z to the n plus 1 I z n all over zn, that complex conjugate. All right. Now we are also told that z, the 0, the magnitude is 1. And that's about it. Not much more than that. So we have to somehow figure out how many Violets there are for z to the o, with the only other clue that z to the 2005 is equal to 1. All right. So we obviously, the heart of this question is this formula. So let's see what we can get. Now, in this question, I really want to utilize this right here, because that is going to help me a lot to get a pattern. So how do I get that? Well, what I can do is I can multiply top and bottom here by zn, like this. Okay? If I do that, I get zn all squared, and at the bottom I'll get zn conjugate times zn. But as I showed over here, this is just equal to that, the square of the magnitude of zn. All right, so I can just put that in here, zn squared, I zn all squared. Okay, that helps me because now I just have zn to worry about. I don't have to worry about the conjugate, right? Because here you've got the conjugate, and I just didn't want to worry about that. So now we've got a nice clean formula that we can proceed with to figure out this question. So the very first thing is, of course, let's start with z0 and z1. So we're going to let n equal to 0. That gives me z1 is equal to I z0 all squared over z0, the magnitude squared. Correct? I'll do this slowly so that there's nothing that skips you and you get lost. Now z0 they give you in the question. The magnitude they tell you is 1. So we'll plug that in. And we get 1 for the denominator, 1 squared actually, right? Because this is equal to 1. Now the numerator, what do I have here? Is there anything I can do? Not really, right? It just basically becomes I z o squared. That's it. That's about as far as I can go. So z1 just is I z o squared. Okay? Now let's move forward. Let's go to z2. Using this formula right here. So z2 would be I times z1 all squared. So z1 is I z o squared, like that, all over zn squared, and in this case is 1, so it'd be z1 squared, and z1 squared is basically I z0 squared, the magnitude all squared. Okay, so this at the top there becomes I times, you're going to square what's in the bracket, so I squared z0 to the power of 4, like that. And then on the denominator, we're going to have the magnitude of this all squared, but that is 1, correct? In the question they tell you that it's 1. This denominator here might cause a little bit of confusion, but if you are familiar with the properties of complex numbers, you'll be able to figure this out pretty quickly. This breaks up into I magnitude times z0 squared magnitude, and then that like that squared, and then I magnitude is 1, so 1 squared is just 1, and then z0 squared, you can put it outside like that. That's part of the properties. And then z0 we know is 1. The question tells you that. So 1 squared is 1, and then that squared again is 1. So the denominator just becomes 1. So all you're left with in this question is the numerator, and then I squared is negative 1. So this just becomes negative I z0 to the 4th. So if I can squeeze that in there, negative I z0 to the 4th. All right, let's do just one more. I think one more should be sufficient. Z3. Using our formula. And our formula, let's stick that in the screen there. This one right here. So we got I z2 all squared, z2 the magnitude squared, like that. So z2 we have as right here, negative I z0 to the 4th all squared, all over negative I z0 to the 4th magnitude squared. So this becomes negative I squared. Well, negative 1 squared is just 1, and then I squared is negative 1, and then z0 to the power of 8. And then the denominator, using properties of complex numbers, we've got negative I magnitude squared times z to the 0. We can bring that out. 4th all squared, like that. This numerator becomes, let's see here, negative I z0 to the 8th, and then the denominator I squared, well, the magnitude of negative I is 1, and then that would be 1 if you square it, and then z0, the magnitude is 1, and then that to the 4th and then squared is also 1. So the denominator is just 1. So let's see, what did we get so far here? We've got z to the 1 is I z0 squared. Z to the 2 is negative I z0 to the 4th. And then z to the 3rd is negative I z0 8. So you can keep doing values of n, and you will find in general that this equation becomes z to the k is negative I z0 2 to the power of k. That is our formula. And you can get that by doing more powers of k to convince yourself, z4, z5, and so on. So our question wants us to figure out how many possible values are there for z to the power of 0. Now, we are given a clue that z to the power of 2005 is equal to 1. So therefore, when k is equal to 2005, we have the following situation. Z to the 2005 is equal to, using this formula, minus I z0 2 to the 2005. Now we are told that is equal to 1, so substitute 1 there. You get minus I z0 2 to the 2005, like that. Now multiply both sides by I here and I here, And this will give you just I on this side. This side will be I times negative I, or negative 1 times I squared. It's probably a better way to write it. 2 to the power of 2005, like that. Now I squared is negative 1. And then we have another negative 1. So negative 1 times negative 1 just gives you 1. And you're just left with z to the power of 2 to the 2005. So there you go. We've pretty much boiled it down to a complex equation. And this tells me that z to the 0 has 2 to the power of 2005 solutions according to this equation, because it would be the root of I, but 2 to the 2005, like that. So you'd have that many roots of the complex number I. So 2 to the 2005 is the answer. And let's see here. That would be answer choice E for number 22. Let S be the set of ordered triples x, y, z of the real numbers for which log of x plus y to the base 10 is z, and the log of x squared plus y squared to the base 10 is z plus 1. There are real numbers a and b such that for all ordered triples x, y, z in S, we have x to the power 3 plus y to the power 3 is equal to a times 10 to the power of 3z plus b times 10 to the power of 2z. What is the value of a plus b? 10 to the power of z is equal to x plus y, according to this formula. And 10 to the power of z plus 1 is equal to x squared plus y squared, according to this formula. So this one, if you break it up here, it can be 10 to the z times 10 to the 1, like that, x squared plus y squared. And let's see, anything else we can do? X plus y, we can substitute that there, times 10 is equal to x squared plus y squared. And 10 to the power of 2z, since I've got that here, is 10 to the power of z all squared, like that. So that basically means that's x plus y all squared. And then 10 to the power of 3z, which is what we have here, is 10 to the power of z all to the power of 3, which is x plus y all to the power of 3, like that. And I'm just setting up what we can possibly use as this question moves forward. Now, where do we go from here? Now, we're probably going to need the value of x, y, because I can kind of see here there's a lot of x plus y, and if you do the square of it, you're going to get x squared plus y squared plus 2xy, right? So this is something that I'm probably going to need, and I can figure that out with what we have so far. Because x plus y, if you were to square it, you get x squared plus 2xy plus y squared, right? But x plus y squared, we know, is 10 to the 2z. And x squared plus y squared, this right here, is right here. So that's 10z plus 1, and that leaves me with a 2xy. So we've got 10 to the power of 2z minus 10 to the power of z plus 1, all divided by 2, is equal to xy. All right? So now let's get to the heart of the question, which is this formula right here. X to the power of 3 plus y to the power of 3 is equal to a times 10 to the power of 3z plus b times 10 to the power of 2z. And they want you to find the value of a plus b. Now I immediately notice that if you were to make z equal to 0, those would become 1s, correct? Therefore, that would just leave you with a plus b. So let's do that. That's the simplest way of moving forward. So our formula is x to the power of 3 plus y to the power of 3 is equal to a times 10 to the power of 3z plus b times 10 to the power of 2z. And as I previously mentioned, let z equal to 0. And if you do that, you get x to the power of 3 plus y to the power of 3 is equal to a. This just becomes 1, right? Because 10 to the power of 0 is 1. And this becomes just b, because 10 to the power of 0 is 1. And there you go. Now I just have to find a numerical value, because they want a numerical value, correct? Yeah, it's all numbers in the answer choices. Okay, finding this shouldn't be too hard now that I have simplified it greatly. I have to find the numerical value of this. Okay, let's see here. Well, I let z equal to 0, right? So a lot of this I've already figured out, so I just have to figure out numerical values. Okay, I let z equal to 0, so that means that x plus y is equal to 1 when z is 0. X plus y squared is also 1. X plus y to the power of 3 is also 1. And this one right here, xy will be 1 minus 10 over 2, which is equal to negative 9 over 2. Yeah. All right. Let's go back and figure out what we can get for this guy. Well, x plus y to the power of 3 is probably what we're needing to expand to find some sort of a numerical value for that. All right, let's do that. X plus y, x squared plus 2xy plus y squared. And then if you expand that, you get x to the power of 3 plus 2x squared y plus x plus 2xy squared plus y to the power of 3. Grouping these together, we have x to the power of 3, y to the power of 3. And then we have 3x squared y plus 3xy squared. And that's all equal to x plus y to the power of 3. So now we can start putting in values. X plus y to the power of 3 is 1. So put that in there. X to the power of 3, y to the power of 3, that's what I'm trying to figure out. And then let's see what factors here. 3xy, x plus y, like that. X to the power of 3, y to the power of 3. xy I figured out already, I think. Right here, negative 9 over 2. So put that in there. 3 times negative 9 over 2. And then x plus y, I believe that was 1. Yeah, it's 1. All right, we're getting somewhere. So we got 1 there. So I can figure out this. Let's just not make any mistakes here. So I've got 1 plus 9 over 2 times 3 is x to the power of 3 plus y to the power of 3. So 1 plus 27 over 2. So I'll get a common denominator. And I've got 29 over 2 is equal to x to the power of 3, y to the power of 3. And that is what a plus b is. So therefore a plus b is equal to 29 over 2. That's the answer. So 29 over 2, where is that in the answer choices? 23 is B. All three vertices of an equilateral triangle are on the parabola y is equal to x squared, and one of its sides has a slope of 2. The x-coordinates of the three vertices have a sum of m over n, where m and n are relatively prime positive integers. What is the value of m plus n? Let's first draw a diagram to get an understanding of what this question is referring to. So here we have our parabola, and our equation is y is equal to x squared. And we are told that we have 3 points, and since all 3 points are on the parabola, they are of the form a squared, b squared, and c squared. And when you join those 3 points, you create a triangle that is equilateral. As you know, that means all 3 sides are the same. And they want you to figure out what is A, what is B, what is C, and then add those 3 up. So eventually you will need to find A plus B plus C, and it will equal some fraction, m over n, and then they just want you to add m plus n. Okay, where do we begin? Well, the first thing, of course, is this clue that they give you that one of those lines has a slope of 2. Well, looking at this, obviously that's got to be this line right there, because no other line could possibly have a slope of 2. This one will have a negative slope, and this slope is, it's closer to 1, right? Because it's kind of almost a flat line, not exactly a flat line. All right, let's work with this line right here and the fact that it has a slope of 2. Slope, of course, is figured out by rise over run, as I'm sure you know. So the rise in this case is b squared minus a squared. The run is b minus a, and that is equal to 2. So if you factor this out, you get b minus a, b plus a, and this is b minus a. So the b minus a's cancel, and you're just left with b plus a is equal to 2. Great. We've got a plus b is 2. And now all we have to do is find c, and we're done. But finding c is not as easy as finding a plus b. All right, so at least we got some of it done. Now, in the remainder of the question, because we have 2 variables here, b and a, I'm going to let a equal something and b equal something, and that will very much help us. Now, the fact that they're both the sum, if you add them, is equal to 2, helps us because we can let a equal 1 minus k and b equal 1 plus k. And now I've given both of them a value that has the same variable. All right, so that immediately we can figure out a few things about this question. The first thing, of course, is I want to figure out the midpoint of this line right here from A to B. So the midpoint is approximately here, I would say, this red dot. Now that midpoint you can figure out with the midpoint formula, be a plus b over 2, and then a squared plus b squared over 2. Well, a plus b we just figured out was 2. So a plus b is 2, divided by 2 is 1, so that's 1. And then this one here is not as obvious, so I'll just leave it as a squared plus b squared. But I don't like the fact that there's 2 variables, so I'm going to use these 2 to figure out a squared plus b squared. A squared plus b squared over 2, that looks like 1 minus k squared plus 1 plus k squared all over 2. So that gives me 1 minus 2k plus k squared plus 1 plus 2k plus k squared all over 2. And this looks like k squared is going to add twice and then the 2's all over 2. So that's just k squared plus 1. All right, so this becomes k squared plus 1. All right, a little bit of progress there, right? Okay, so now where do we go from here? Well, the next thing I'm going to do is I'm going to draw a perpendicular from C down to the base AB, like that. And that's a perpendicular there. Now, the reason I did that is because we can again use the fact that we know the slope. The slope here was 2, right? Well, if the slope there is 2, then what's the slope of that line? because that line is perpendicular, the slope will be the negative reciprocal of 2. So the negative reciprocal of 2 is negative 1/2, and therefore that's the slope of that line. So we can use our points to figure out a relationship. Rise over run again. So I have 1 k squared plus 1 minus c squared rise over run 1 minus c. Cross multiply here and I'll get negative 1 times this gives me c minus 1, and then 2 times that gives me 2 times k squared plus 1 minus c squared. Alright, I think that's about as far as I can go. I've got 2 variables and we'll use this later. I'll just write use later. Hopefully I can get another equation with c and k. If I can, then I'll be able to solve for c, and that's exactly what we need to figure out our question. Okay, let's keep going here. Where do I want to go next? I think I'm going to use the fact that this is equilateral. That has to be used somewhere in this question, otherwise they wouldn't have mentioned it. And I think I'm going to use the fact that we have a certain ratio for these sides. In any triangle that's equilateral, as you are well aware, these angles are 60 degrees. And because those are 60 degrees, this is going to be 30 in that triangle, just that triangle. And therefore, in any 60, 30, 90 triangle, the ratio of the sides as 1, 2, and root 3, as I'm sure you know. So therefore, the ratio of this height to this base is going to be root 3 over 2, right? Because if this is 1, then that is 1 also, like that. So root 3 over 2 would be the ratio of this height to the base. So I can figure out both of those using my points. All right, let's do that. So we're going to figure out the length of CD. CD, of course, is from here to here, where this is D. D is the point where it touches AB. So CD, using our points, let's see here, I'll just put it in the screen for once. We got 1 minus c all squared plus k squared plus 1 minus c squared all squared, all under the square root sign. Okay? And let's see, can we substitute anything in this? Yes, right here. We can substitute that. This looks awfully similar to that, correct? So that is essentially just going to be c minus 1 over 2 all squared, like that. And this just becomes 1 minus c, or we can flip it since it doesn't really matter since it's being squared, like that. And therefore this is going to be c minus 1 over 4, c minus 1 squared over 4. So if you add that fraction, it'll be 5 over 4 c minus 1 all squared. All right, great. Now before I figure out the length of AB, I want to revisit that triangle again to sort of hammer this concept home. So we had this equilateral triangle, correct? That was in our diagram. And this is, of course, going to be labeled in terms of its degrees. This is 60 degrees, this is 30 degrees. And the ratio of the sides, of course, is 1 right here. This is 2, and this green line is root 3. Now, this, therefore, A to D is also going to be 1 in terms of a ratio. So if you're going to do the ratio of, say, CD over AB, it would be root 3 over 2. Okay? So that is what we're going to use. CD, therefore, is equal to root 3 over 2 times AB. Now, CD I just figured out. If I can figure out AB, then I'll be set. So A and B we can figure out. If you remember, a, the coordinates, were a and a squared, correct? But we had set a equal to 1 minus k. So 1 minus k and 1 minus k all squared. And then b was b and b squared, correct? But we had set b equal to 1 plus k. So this will be 1 plus k, 1 plus k all squared. Okay? All right, so let's figure out AB. AB is going to be 1 minus k squared minus 1 plus k squared. This is the distance formula, all squared. And then we add to that 1 plus k minus 1 minus k, all squared, all under the square root sign. So AB is therefore, let's do the expansion now, 1 minus 2k plus k squared minus 1 minus 2k minus k squared. That's all squared. And then the next part is just, let's see here, 2k, all squared. And this is all under the square root sign. So let's see, the first one, what do we get? I believe we get just minus 4k, all squared. And then 2k squared, of course, is just 4k squared. And then this is 16k squared plus 4k squared. All right, things are looking pretty good here. So we've got 20k squared root. Okay. And then now we can use this formula. We've got CD is equal to root 3 over 2 AB. CD we got over here, 5 over 4 C minus 1 all squared, root 3 over 2 AB. We just got 20k squared root. All right, we've got another formula in terms of C and K. Let's simplify this a little bit. Let's square both sides, get rid of all those roots. C minus 1 squared. Squaring root 3 over 2 will give you 3 over 4, and then 20k squared like that. Okay, now at this point, let's see, can we simplify? I believe so. 3 times 20 is 60, divided by 4 is 15. And then if I put the 15 down here, I'll get C minus 1 squared over 12. Or you could have done that in many ways, but either way, it's fine. All right, that's what I got. So I've got this one, and then I had another one from before, right? I had another relationship right here. Use later. Okay, let's copy that down there. C minus 1 is equal to 2 times k squared plus 1 minus c squared. Okay? C minus 1 is equal to 2 times k squared plus 1 minus c squared. Okay. All right, we got two equations, two variables. Now we can solve. So I'm going to substitute the value of k squared for that, as that, I should say. So c minus 1 is going to be 2 times k squared, which is c minus 1 all squared over 12, plus I'm going to get a common denominator, so 12 over 12 minus 12c squared over 12, like that. And this will give me 2 over 12, which is 1 over 6, so I can bring the 6 over here, and then this will just be c minus 1. This side expanding gives me c squared minus 2c plus 1 plus 12 minus 12c squared. Put everything on one side. Let's see what we get here. C squared minus 12 squared, 11, so put the 11c squared here. Plus 6c minus 2c, bring the 2c over, you get 8c. And then we have minus 6 And then on this side, you'll have 13. So minus 6 minus 13 minus 19 is equal to 0. Let's see if this factors. I hope it does. I don't know how to, otherwise I have to use a quadratic. 11c 19 and 1? 19 and 1 plus minus. So c is equal to 1 or negative 19 over 11. Okay, finally we got it. We got c. So if you remember, a plus b plus c is what we want to figure out, and that is equal to m over n. A plus b we figured out at the very beginning was 2. If c is 1, then we get the following. M over n is equal to 3. 3 over 1. And therefore m plus n would be equal to 4. Is 4 one of the answer choices? No, it's not. Okay, it's fine. Let's try the other value for c. C therefore must be this guy, so a plus b plus c, 2 plus, well actually it would be negative 19 over 11. So I'll get a common denominator. 11 is the common denominator, so we got 22 minus 19 over 11. 3 over 11 is my m over n, and therefore m plus n would be 3 plus 11, which is 14. And let's see if 14 is one of the answer choices. I think it was. And it is. Number 24 is A. 6 ants simultaneously stand on the 6 vertices of a regular octahedron, with each ant at a different vertex. Simultaneously and independently, each ant moves from its vertex to one of the 4 adjacent vertices, each with equal probability. What is the probability that no 2 ants arrive at the same vertex? This is a octahedron, and let's say we have ants represented by the red dots at each of the vertices, and of course we've got 6 of them, and they're saying that these ants are going to start moving. And let's start labeling these vertices. We got A here, B, C, D, E, and finally F at the bottom. Now these ants move. So for example, this ant here will move down to this position. And this ant here perhaps will move down to this position, and so on, right? What they're saying is that you want to be able to create a situation that when they do move and land at some other adjacent vertice, that no 2 ants are at the same vertice. So if they started in the positions of A, B, C, D, E, and F, if they move, they have to all move and land on a different vertice. So for example, they could end up, A could go to, let's say, B, B could go to C, C could go to D, D could go to F, E could go to A, and F could go to what's left over, which I believe is E. See, this is a scenario that works. I hope I did that properly. So what doesn't work is if, 2 ants end up at A. So A moves to D, but then F also moves to D. That's not going to work. That's no good. So they want you to figure out that probability. Well, with any probability question, the very first thing is, of course, to figure out the denominator. That's going to be much simpler. The denominator in this question is going to be the number of possibilities, total number. Well, each ant has 4 possible vertices that can be traveled to, 4 adjacent vertices. So there's 6 ants, right? 1, 2, 3, 4, 5, 6. Each ant has 4 possible choices. 4 times 4 times 4 times 4 times 4, which is 4 to the power of 6. That is the denominator. Now the numerator, of course, is what we have to figure out, and that's a little bit more challenging. So here we go. So to break this problem up into something that makes it easy to understand, I'm going to first start with the ant that's at A. And let's say the ant at A travels to B. Correct? Now, the ant at A has how many possible choices? 4, like any ant. They can only go to an adjacent vertex. So if you're originally here, you can only go to B, C, D, or E. Can't go to F because that is not an adjacent vertex. So when A travels to B, that is only one of 4 options. All right? So whatever scenario I get for this, at the very end, I will have to multiply it by 4. Correct? Because B is only one of the 4 options. The same scenario will hold true for going to C, for going to E, and for going to D. So if you can figure out for 1, you can just multiply at the end by 4. Okay, so that's where I'm starting. And when I start with A going to B, it's going to create 3 cases for me. Case 1, case 2, and case 3. Case 1 and case 2 and case 3 for what? We've already decided that A is going to go to B. Case 1, 2, and 3 for F, for this guy. Concentrate on him now, because he's on a vertex that is not adjacent. So case 1, we're going to put F going to C. Okay? He's going to travel from here to here. And A is traveling from here to there. All right? That is my scenario. So here we go with case number 1. Now, how many ants did we have? We had A, B, C, D, E, and F. These are the ants. These are where they are originally. Now, we have decided in our question that A is going to B, correct? So A is going to B, like that. So we don't need to worry about A, and we don't need to worry about going to B. Now, F, we also decided, is going to C. So F is going to C. Now, we need to figure out where does everybody else go. Bring the diagram back so it helps you visually. B, the ant that's at B, what possibilities does he or she have? He can go to either A, E, or F. Okay? A, E, or F are the choices for B. What about C? The ant that's here, where can that ant go? Well, only the adjacent vertices. C can go to either A, D, or F. What about the ant at D? What are the choices there? Well, can go to A, E, or F. A, E, or F. What about C? Why can't I go C? Well, because C is already taken. We have placed F there, remember? So just in case you're wondering. And then finally, E in a very similar way. Where can E go? E go A, D, and F. All right? So hopefully that makes sense. So let's keep this. All right, now we have to figure out our scenario. So here we go. B. Let's start with the very first one. Let's go in order so avoid any confusion. B can go to A. Great. How about C? C, let's go right in order. Can I go to A? No, because B's already gone there. And we don't want any 2 on the same vertex. So let's put C at D. Let's go to the next one. D. Where can D go? Can it go to A? No, no, no. We don't want that scenario. But it can go to E. Then our last guy, E. B, C, D, E. Where can E go? Can he go to A? No. D? No. He has to go to F. All right? So that's one scenario. Let's say how many more. And I'll let you kind of do this. I'll just write them out. right? Because I don't think you really need to hear me rationalize every single one. So I will write out all the possibilities and I'll come back and we'll discuss it. So there you have it. There are all the scenarios in a very systematic way. I've written them all out. This is scenario number 1, number 2, number 3, number 4, 5, 6, 7, 8. So we've got 8 possible ways that this can be done with F going to C and our original A going to B. Okay? So now let's move on to case number 2. A is still going to B, but now case number 2 involves F going to D this time. And in a very similar way, I won't torture you with all the details because by now I think you figured it out. I will just write out the possible ways that we can place all the other ants. And this is the possible scenarios. And this time we only have 4 for the case where F goes to D. And then the parent is always the same, right? The parent is A going to B. And then we have one final scenario for A going to B, and that is where case number 3 comes in, and that is where F is going to E. And the good news is that this is the exact same as case number 1 in terms of the way you would approach it. So without laboring this to death, I'll just write that it's 8 possible scenarios, very similar to the way I did here in case number 1. So there you go, we're done. 8 plus 4 plus 8 is 20. 20 possible ways that you can arrange these ants if A is going to B. Now remember I told you at the beginning that that's only one of 4 possible options for A. If A goes to B, you've got 20 possibilities like we just figured out. But A can also go to C, D, or E. So if A goes to B, you've got 20, just like how I did. But if A goes to C, we can also figure out 20 ways. If A goes to D, we can also figure out 20 ways. And then finally, if A goes to E, we can also figure out 20 ways. So in total, it's 80. And if you remember, probably by now you've forgotten the denominator. Our numerator we just figured out was 80. The denominator was 4 to the power of 6. So this is the final answer. Now this is equivalent to 80 over 4096, the fraction. If you divide top and bottom by 16, you'll get 5 over 256, and that is in lowest terms. 5 over 256 is choice A for number 25.